Geometry transformations. Translations. Before we start talking about transformations, we need to establish a convention for how we refer to each of the quadrants in the coordinate grid. The convention that we follow is that this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So they're going counterclockwise in their numbering. When we're doing transformations, we refer to the shape that we started with as the original shape. And the new shape that's created after the transformation is referred to as the image. Another convention when doing transformations is the naming of the vertices in the original shape and in the image. In the original shape, we typically label the vertices with letters A, B, C, D, and so on. The corresponding vertices in the image are labeled A', B', and so on. The exponent 1 in this case denotes prime. Remember in the Despicable Me movie, there's a character named Vector and he describes himself as having magnitude and direction. When we're doing a translation, the translation can be described as a vector in one of two forms. In brackets, x, y, where x and y represent the right or left and the up or down movement of the shape in the translation. It can also be written in brackets with x on top of y, but there's no line across in the middle like you would have in a division statement or in a fraction. So this green line here is referred to as a vector, and it can be described in these two ways. So we can write it in either of these ways, in the square brackets side by side, or one on top of the other without no middle line across, so without the division sign or the fraction sign in between it. The reason we do that is that in a coordinate plane, a vector can be broken down into its x and y changes. And for those of you who remember your Pythagorean theorem, the magnitude, or the length of that vector, you can determine by using the x and y coordinates as your a squared and your b squared in your Pythagorean theorem to find the c squared, which you can reduce down to find c, which gives you the magnitude of the vector. Let's start by talking about a translation first of all. Translation means we're taking the shape, in this case we've got a triangle, and we're moving it right and left and or up and down on the coordinate plane. As an example, let's say we're going to focus first on this one vertex here at 3, 2, and we wanted to move it over to -6, 1. And we can see that the total x distance that it moved, so x moved a total of 9 spaces, so it moved 9 to the left. Now we look at the y coordinates, and we can see that it changed by 1, it went down 1, so y, it went 1 down. We're going to use those same movements, those same changes, for each of the vertices. So let's look at this coordinate now. We've got 8, 7. We want it to go 9 left, so if we're going to take 8 and subtract 9 from it, we're going to end up at -1, so it's going to be somewhere along here. And the 7 is going to go 1 down, so it's going to end up at 6. So we're going to end up at -1, 6, which is right there. Looking at the last coordinate, 9, 4, if we subtract 9 from 9, we're going to end up at 0, so we know we're going to be somewhere right on the y-axis. And the 4, we're going to just subtract 1 from it, so it's going down to 3. So we're going to end up at 0, 3, which is right there. We can then connect up those 3 points, and we have the image of our translation.